Welcome guys. In this video we are going to focus on question 2 from section C of Science paper 1 for the year 2023 for the internals. Now this question is under the topic of thermocouple thermometer, so that is under the measurement of temperature. Now we have the question 2 reads, table C2.1 shows results of temperature in degrees Celsius against current in milliamps obtained when a thermocouple thermometer was calibrated by immersing the cold junction in pure melting ice at 0 degrees Celsius and the hot junction placed in water of different temperatures. So according to our table, the table is there showing us the values that were gotten as these hot junctions were placed in different temperatures. So the first row is showing us the temperature of hot water junction. Then the second row is showing us the current in milliamps. So when the temperature was at 0, the current was at 0.00. When the temperature increased to 25, current also increased to 0.01. Then 50, 0.2, 75, 0.23, 100, 0.4, 125, 0.5. So as we can see, the relationship between the temperature and current in our case is directly proportional, because as the temperature increases, so is current. Now, in mathematics, you are given the scale. You are told using a scale of this to represent this. Now, unlike science, you have to make your own scale. We are not given the scale, so we have to make our own scale based on our numbers that we have in our table. So question A, plot a graph of temperature in degrees Celsius against current in milliamps. So the factor that comes after against goes in the x-axis. So our current will be in our x-axis, then temperature in our y-axis. So let's begin by coming up with the scale in the y-axis. So you're going to say 2 centimeters represents what units. So let's see the difference between these numbers. So the difference between 0 and 25 is 25, or the number that was added was 25. Then 50 and 25 is 25. So here they added 25. Here they added 25. What of here? They added 25. Here they added 25. Here they added 25. So we are going to say 2 centimeters to represent 25 in the y-axis. Right, we move on to the x-axis. The x-axis from here is 0.1, so they added 0.1, then 0.1. If we round this number, we can get 0.3, so here we're going to add 0.1, also here 0.1, also here 0.1. So in the x-axis, I'm going to say 2 centimeters to represent 0.1 unit. So this is what you can use to come up with your own scale in science. Now let's draw our graph. Okay, so we'll say it will have 0, then this is our x-axis, so 0.1, here 0.2, 0.3, 0.4, 0.5. So the x-axis, we are told, represents the current in milliamps. Now what of the y-axis? So we say 2 centimeters represent 25 units. So we have 25, 50, 75, 100, 125. So this is our y-axis, and in the y-axis we have temperature, of hot junction in degrees Celsius. So let's begin plotting. So the first pair is 0.00, so that is just the origin. So this is where our point. Then the second one is 0.1,25. So 0.1,25 is here. The second one is 0.2,50. Then for this one, we can just round it off, so we can get the 1 from 9. We add on 2, so this becomes 0.3,75. So 0.3,75 is here. Then 0.4,100, 0.4,100, then 0.5,125. So the important thing that you're supposed to have if you are dealing with the graphing in science is the explanation that you are supposed to give depending on the type of the curve that you formed. Now make sure that you use a rule. So if we are to use a rule, we can see that what we have formed is a straight line. So what interpretation can we get if we have a straight line? So the straight line, like this one, is telling us that the temperature is directly proportional to current. How did we know that this is directly proportional? Because the line is linear. So that's what you're supposed to do, which simply means that if temperature increases, current is also increasing. That is the simple definition that we can give to a direct relationship. Now let's move on to the other question. So the other question is use the graph to determine the temperature. Number 1, the temperature of the hot junction with the current is 0.35. So we are going to use 0.35 to find the temperature. So how can we do this? Let's go back to our graph. So we need to identify where 0.35 is. So 0.3 is here. So 0.35 is between 0.3 and 0.4. So I'm going to say 0.1, 2, 3, 4. So 0.35 is here. So what are we supposed to do now? You need to draw a dotted line. So you draw a dotted line until it touches our curve. Then from there you turn 90 degrees to the left. So the point where this line will cut the x-axis is our final answer. So that's what you're supposed to do. You use the given information. In our case, you use current, because current is given, to find the temperature. So which means that at 0.35 the temperature was this number. So what number is this one? So we need also to identify the smaller box, what that smaller box is representing. Since the scale in the y-axis is 2 centimeters represent 25 units, so I'm going to say 25 divided by 10. So I'm going to have 2.5. So each smaller box is a 2.5. So here it's 75.2.5. So I'm going to say 75 plus 2.5. Then another smaller one, so plus 2.5. Another one plus 2.5. Another one plus 2.5. So according to my calculation, this is 85 degrees Celsius. So that's our final answer, 85 degrees Celsius. So to summarize this question, we are just saying that when current was 0.35, the temperature was 85 degrees Celsius. Okay, so let's go back to this question 2. So under question 2, current that will flow when the temperature of the junction, hot junction, is 333 Kelvin. So this time we are given temperature, and we are going to use this temperature to find the current. We are going to use the same, but the only difference is that the line will come from the y-axis going into the x-axis. Now, if you look at this temperature, it's given in Kelvin, so we need to change into degrees Celsius so that it is able to match the data that we have in the y-axis. So I'm going to say temperature in degrees Celsius is equal to temperature in Kelvin minus 273. So the temperature in Kelvin is 333 minus 273. So I'm getting 60 in degrees Celsius. So this is now the one that we are going to use. So let's identify the point where there is. So 50, 52.5, 55, 57.5, so 60 is here. So I'm going to draw a dotted line parallel to the x-axis. Then upon touching our curve, I'm going to turn 90 degrees parallel to the y-axis. So the point where this line cuts the x-axis is our final answer. So we have 0.2, 0.21, 0.22, 0.23, 0.24. So when the temperature was 60 degrees Celsius, the current was 0.24 milliamps. So that's how you are supposed to answer. Right, so we move on to question C. So question C, state the physical quantity a thermocouple thermometer uses to measure temperature. So the thermocouple is an instrument, is a thermometer that measures a very high temperature. Now, apart from that, the physical quantity that it uses is heat transfer. So its functioning depends on the heat transfer. Then give one advantage of a thermocouple thermometer over a liquid in-glass thermometer. So the advantage is that it can measure a very high temperature. Then the other difference, or the advantage is that it has a high responsiveness, so it responds quickly. So as we can see, this is how we can answer this question. So that's it for this video. Thanks for watching.